In this section, we're going to explore and prepare the data set that was created last time, that is, the Missouri Schools.save data set. Set it up so that we can do the hypothesis testing using SPSS assignment. First, we'll look at what is involved in doing the SPSS assignment. And to do that assignment, we're going to select the Missouri Schools data set, and we're going to have to do at least one of an ANOVA, t-test, chi-square test, and correlation hypothesis test. And in order to do that, we realize for the t-test we're going to need at least one dichotomous variable, and for the chi-square test we're going to need some variable that has, maybe 2 to 7 levels. So step 1, we're going to find the data file, and we're going to go to the Missouri Schools 2014 data from DESE, and pulling up the data file, it looks something like this. Now, looking at this data file, we see some variables that have, maybe 2, 3, 4 levels. That might work, namely the test. And we don't really see anything that has 2 levels. And what we want to do is we want to first of all explore the data set. And the easiest way to explore a data set is to go to Graphs, and let's Legacy Dialogs, and go to Histograms. And there's lots of different things we could look at. Let's look at perhaps some free and reduced lunch percentage, just to see what that data looks like. And looking at that, we see that this looks pretty normal, probably with a mean about 54%. If we dichotomize a variable like this, we're going to lose a lot of information. So we probably don't want to use this variable as either in our chi-square or in the ANOVA. We might use this as the dependent measure in ANOVA, but we don't want to use it as the independent variable. We'll try a different graph. And let's just look at the percentage points. Looking at that variable, we see that that's really skewed, with most schools scoring up in the above 80%, and many schools, and only a few schools falling less. So that's really not a candidate for dichotomization. Let's look at maybe dropout rate in 2011. That one looks pretty positively skewed, although it's a candidate. Let's do this variable. Let's see if we can, if we divide it about 5%, then we can have a dichotomous variable will be overloaded in the low, but it might work. So let's dichotomize this variable, drop out 2011, and to do that we'll go to transform, recode into different variable, and the input variable will be dropout in 2011. The new name, we'll just call it dropout rate. We'll change that, old and new values. The lowest through 5. Let's make that a 0. 5.01 through the highest, we'll make that a 1. Continue. OK. Going back, looking at our data. We see we've created a new variable with lots of zeros and only a few ones. So it'll be kind of skewed, but we'll go ahead and do that. Let's just change a few things, clean it up a little bit. We don't really need any decimals because that's a 0, 1. Let's change the number of levels to 4. And the values, let's make a value of 0 and call that low for a low dropout rate, and a value of 1 for a high dropout rate. Okay, we'll go back and look at our data view. And looking at this, let's just look at our value labels to see whether what we have looks okay. Now we've got to create another variable. We've got some variables that might work here. In other words, math points to. Okay, that goes from 1, 2, 3, and 4, not very many ones. We might combine 1 and 2 into a single variable. And we'll call that math points 3. Why not? Recode into a different variable, math points 2. And we'll just call this for recoded. Let's call math points 2 recoded. Old and new values. If it's a 1, let's make it a 2. Two, let's make it a 2. If it's a 3, we'll make it a 3. If it's a 4, we'll make it a 4. And for anything else, we'll call it a system missing. We'll look at our data file, 2 3s and 4s with a few system missings. That might work. Again, we'll go to variable view. We really don't need any decimal points here. And we'll make this 4 just to match everything else. All right, let's look at one more thing. Ending grade. And originally I wanted the data file to get things like charter schools versus non-charter schools, public schools versus private schools, religious schools versus secular schools. And the data set might have it in it, but I wasn't able to find it in the DESI data set, and therefore I don't have that kind of data. But I do have this, the ending grade, and I can assume that anything less than 6 is probably elementary. Between 6 and 8, middle school, and 12 would be upper school. So I'm going to recode ending grade into elementary, middle, and upper. So again, we'll go to transform, recode into different variables. We'll change this, and we'll look at ending grade, and we'll call it school type. Old and new values. lowest through 6. We'll give it a value of 1. Seven and 8, we'll give it a value of 2. And value through highest of 10. Through highest, we'll give it a value of 3. And all other values, we'll give it a value of system missing. Okay. And again, we'll go back to our data set and see what we have. We've got 1, 2, and 3. It looks like that worked pretty well. So we've got middle. So what we want to do now is go to, again, we don't need any decimals. We'll make it 4. And value of 1 will be elementary. Two, middle, and 3, high school. Okay, so those are 3 levels. And it's good to document it this way, because when we document it this way, we'll get nicer output. Going back to our data view, we've created a data file that should be able to work to do the hypothesis testing using SPSS assignment.